Sure, you're gonna miss some exciting stuff, so you gotta hurry. Leave your phone here. All right, we're evaluating by hand this. Now, you probably have never seen that before because you've never done this kind of stuff before. That's just a different way of writing this. So this kind of notation simply means a combination of 7 things taken 3 at a time. To evaluate that by hand, here's how you do it. You start with 7 factorial. So they're always going to be fractions, okay? You're going to set them up as fractions. And then in the 7 factorial, that's this number right here. And then in the denominator, you're going to put a 4 factorial and a 3 factorial. Now, where did those come from? Well, to get the 4, you do 7 minus 3, and then this is that number. So that's how it's always going to look. No matter what these numbers are, this is the way you're going to structure it. And we got some more to practice, so don't panic. Now, to evaluate this by hand, remember, we're not typing that button on our calculator. We're doing this by hand. It's easy. What does 7 factorial mean? 7 times 6 times 5 times 4 times 3 times 2 times 1, right? That's what it means. What does 4 factorial mean? 4 times 3 times 2 times 1? Well, wait a minute. Isn't that just going to cancel with all that? What does 3 factorial mean? 3 times 2 times 1. And isn't that 6? Which will cancel with that 6. So all we have left in all that problem is 7 times 5. So it's 35. So doing it by hand should not be causing you any panic. You do have to write it out, but everything cancels. So much stuff cancels. Okay? So let's try the next one. 8C3. What's 8C3 going to look like? 8 factorial, 5 factorial, 3 factorial. All right, numerator is just this number, whatever it is. And then to get our denominator numbers, we subtract these and then use that one. All right, so now we're going to simplify. So 8 factorial. Now, if you want, you don't even need to write out the 5 factorial, because what's going to happen to that 5 factorial? Isn't it going to cancel out all of this? So I'm going to just cancel it out. I'm not going to write it out. And then I still have 3 times 2 times 1. Well, that's 6. So the answer is 56. Stay organized and you can do this. All right, 198. Now, don't panic. This one's easy. Remember, that means 100C98, right? So what would our little formula look like? 100 factorial over 2 factorial 98 factorial. You in agreement? Okay, now what does 100 factorial mean? 100 times 99 times 98 and so on. But notice in the bottom, don't you have a 98 factorial? So isn't that going to cancel with all of that? And the only thing you really have left in the bottom is a 2 times 1. So you have 100 times 99 over 2. But you could cancel 2 into there and get 50. So whatever 99 times 50 is, that will be our answer. 4,950? If I multiplied right, which hopefully I did. So, see, at first, when you saw that 100, you may have like, momentarily panicked. But it's easy because it cancels out almost totally. All right, try the last one on your own. 11C6. That notation means 11C6. It's always C. That notation is always C. Try to do it without a calculator. Alyssa, did you get a setup for it? What did you get for your setup?
That's true.
Like, what did you put on top?
I did it all out.
Okay, but what did you start with on top?
Oh, 11 factorial.
Good. And then on the bottom?
Like 5 factorial.
And 6 factorial. Good. And then, everybody's going to do the scissor her own way. You decided you actually did 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1? Okay, now, when you get to this point, instead of writing this whole thing out at the bottom again, isn't that just this right here? So I'm going to take that 6 factorial and I'm just going to cancel it out with all that. Now I still have a 5 factorial, so I'm going to write 5, 4, 3, 2, 1. So remember, this is gone. So I have that over this. Okay, now you're just going to start canceling, right? So 5 times 2, we'll take out the 10. 4 will go into 8 twice. And 3 will go into 9 3 times. So my whole denominator has canceled, and it always will. And I have left an 11, a 3, a 2, and a 7. Now this one's a little harder. This one's a little more arithmetic.
Where's this one? I didn't even see this. Oh.
So let's see, that's 66 times 7.
462?
42. 462, is that what you said?
Yeah.
Yep. That's your answer, 462.
What?
Is there one for P? Oh my
What?
gosh. Is there like the same way to do this for P?
There is. So I can share that with you another time. I'm not doing that right now. I don't want to get people confused. C's are used more commonly than P's, like Pascal's triangle, all that stuff. So I'm just kind of focusing on that. But there is a formula for P's also. All right, there's one more. I didn't realize it. 10C7. This one won't be as hard, in terms of arithmetic. So would you do 10C7 for me? See if you can come up with a number. She's got a number. 120? 720? 240? Oh, we got some options.
And 120.
120? That's 2 of those. I think we got 2 of those. All right, let's check it out. What's our formula? What's the initial setup for this? 10 factorial over 3 factorial, 7 factorial, right? Is everybody okay with that? Okay. So now 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And some of you aren't going to write all that out. I am. It's okay. On the bottom, I have 3, 2, 1, 7, 6, 5, 4, 3, 2, 1. So I have written everything out. You don't have to write everything out, but if you're not getting the right answer, you might want to write everything out.
Yeah, 120.
So 7 down cancels out. 3 goes into 9 3 times, and 2 goes into 8 4 times. And bottom's gone. The bottom will always go away. You will never end up with a fraction. You always start with a fraction, but you'll never end up with a fraction. And the answer is 120. So those of you that didn't get 120, did you find your mistake?
I just have to.
Okay? Now, we're not done. I hear some of you packing up. We got a couple other things to do here real quick. So, I want to start with a little basic definition that I want you to add right here at the very beginning of section 9.3. 2 basic definitions, actually. Can anybody tell me the definition of probability? When we talk about probability, we say the probability is this. What does that mean?
Chance.
The chance of what?
Something to happen.
Getting a particular result, right? And normally, it's the result that we want, right? What's the probability that it will be sunny? What is the probability that I will win? What is the probability that horse will win, right? So, the definition of probability is a fraction. Probability is always a fraction or a decimal. It's the number of successful outcomes. That is the number of ways you can get what you want over the number of total outcomes. So for example, if and again, we're getting ready to do problems, but not yet. I'm just doing this for the purposes of the definition. If I roll a die, you know what a die is? A little cube that's got 1 dot on one face and 2 on another one, okay? What is the probability of getting a 6? 1 out of 6. Because there's 1 6 on the die, and there are 6 total faces on the die. So what's the probability of getting an even number on the die? 3 out of 6. Because there are 3 evens, still 6 totals, and we would reduce that to 1/2. Okay? Now, probability to the mathematician is different than odds. Now, out there in the world, people use those 2 words interchangeably, but to the mathematician, they're different. Odds are the number of successful outcomes over the number of failing outcomes. So in other words, it's the ways you can get what you want over what you don't want. Okay? So let's come back here. What are the odds of getting a 6? If I roll that die, the odds of getting a 6 are 1 to 5. And normally we read odds sideways like this. That's the same as 1 over 5. But normally they're written this way to distinguish them from probability. So why is it 1 to 5? Well, there's still 1 6 on the die, and there are 5 non-6s on the die. So this means there's 1 way to get what you want, and 1 way to win, 5 ways to lose. So what about the odds of even? That sounds weird. What are the odds of getting an even number?
3 to 3.
Well, wouldn't it be 3 to 2? Oh no, 3 to 3. Sorry about that. Why did I say 2? 3 to 3? Because there are 3 evens and there are 3 odds. So that would reduce to 1 to 1. And what that means is you have exactly the same chance of winning as you do of losing. Well, tomorrow or next time, we will actually start in with a conversation about computing probabilities and odds. Right now, I want to just throw a couple of questions at you to get ready for our quiz tomorrow. Okay? So, you don't have to write these down, let's just see. Let's have some oral participation here. How many ways can I line 10 kids up out in the hallway? Very good. How many ways can I arrange the letters of the word Ford?
4 factorial.
4 factorial. There's no repeat letters in that word, right? No repeat letters in that word. How many ways can I choose a jumper, a shirt, and a sweater if I have 5 jumpers, 8 shirts, and 2 sweaters?
5 times 8 times 2.
5 times 8 times 2. 5 times 8 times 2. I'm gonna take 3 of you on a field trip. If there are 16 of you altogether, how many ways can I choose? 16 C3. C3. Aren't we all going on the field trip? Yep. Speaking of that, it's kind of a bummer. It's kind of a tradition that the Precal kids go on my Precal kids go on a field trip every year. We haven't been able to do it the last 2 years, and it would have been this week because we always do it right around Earth Day. And today's Earth Day, so it kind of stinks that you guys missed out. Well, I'll tell you about it sometime. One more question. One more question. How many 5-card hands have exactly 3 hearts? Right, now spend a moment thinking about that for a second. How many 5-card hands have exactly 3 hearts? I like the 13C3. Where'd the 13 come from? 13 hearts. 3 because I want 3 hearts, right? Now, here's the tricky part. It's a 5-card hand. So I have picked 3 hearts. What else do I need? I need 2 other cards. And what do the other cards have to be? Non-hearts. How many non-hearts? 39. Non-hearts? Very good. 13 clubs, spades, and diamonds. And I'm going to pick 2 of those. And I'm going to multiply those. That's a tough question. Very good job.
Is that a
Very
bonus?
good job. Huh? You guys are so smart. I might put that on the regular.
That's not right.
Way to
Okay.
go, Jay.
Wow. Wait,
all
I
right.
can use one of my birthday bonus or my birthday bonus?